I hope you're excited. We're about to learn. You're about to learn the secret of the world. Hello, everybody. Are there people there? Good morning, Fuzzy. CS202 student Synthos, Yang, welcome. Hama, welcome. Uchu, good morning. Chef, good morning. YCS, good morning. So, assignment 3 was due on Sunday, right? And the late deadline was yesterday. I was looking at the submissions. It looks like most of you did pretty well on that one. Did that assignment go smoothly? There were still a few of you who did the Sunday night cram, which, like I said, don't blame you, but I know you cut it close. You cut it pretty close for the most part. So get started earlier, please. It makes life easier for me. Turn that down. But yeah, that was a good assignment. I think a lot of you was able. English. A lot of you were able to not only kind of understand inheritance, but better understand objects and how those work. A lot of you had some problems with that weapon slot in there. That's just another class, right? It's just another object. And so you were all able to get some good practice with that. Now today we're going to start our new subject, which is pointers. Pointers and addressing, all this kind of stuff. So we'll be working on that today. The next assignment will be popping up here probably tonight or tomorrow. Yeah, thanks, Fuzzy. I appreciate that. That was the goal. And it wasn't a huge workload, but it was a good workload, right? It wasn't too bad. I'm really happy that that helped you get a good understanding. I do kind of like maybe not providing a main file for you. I know for the most part that messed a lot of people up, but I think you got to get in there and declare your own objects. You have to know what you're typing. You can't just, kind of fill in the instructions and then hope it'll all come together. I think it's very important that you make your own main file and declare your own objects and test those functions. Now, just for fun, as I said, the next assignment will be popping up today or tomorrow. I don't know when the deadline for that will be. We'll see how far we get. But this is a sneak peek of it. Does anyone know what this is? I saw a guess in the Discord chat. It wasn't really a guess, more so something that's gonna make us cry. I don't know about that. But does anyone? Yeah, Swift got it. This is musical chairs. We're gonna simulate musical chairs. Okay. So this is gonna be a lot of fun. I hope. It's not gonna look quite like this. I was just kind of dinking around with it, but that's exactly what it is. All right. So, Mel, you're welcome. I'm going to blow my nose real quick, and we'll get started today. Oh, don't need to do that, but I do need to do... Okay, so we are going to learn about something. It's going to be kind of hard to understand. All right, it's going to be kind of hard to understand. So we're going to start pretty basic. It's going to be with just addresses. We're going to figure out what addresses are, okay? I'm going to see if there's anything I want to get out of the way before that. And there is. So before we start with addresses, let's actually start with something called an explicit conversion. Now, you may have to do this, you may not. I don't expect you to be doing it in this upcoming assignment, but it is good to know about. So usually when you want to convert something to a string, what do you do? Does anyone know? Usually if you want to convert something to a string, what do? You use this function called toString, right? So that is a function. This is a member function that belongs to the... It's a static member function, in fact, I think. Might even be just a global one. Since you don't have to use the scope resolution operator to call it, from the string from the string library. Got to get my things right here. That will convert whatever you pass into it into a string. Now don't forget that strings are objects from a class. And explicit conversions don't work with class objects. Okay, so that's kind of what I'm bringing up. You have to declare something like toString if you want to convert things in your class. So if you want to convert data types for your class, declare function like toString. So now that you know that toString is not an explicit conversion, we're going to talk about what an explicit conversion is. Simply put, we're going to convert one type to another. Convert one type to another, as long as that type is not a class. So some people might refer to these as primitive types. So the types that kind of work with this will involve, say, int. You can do a float. Doubles do work. cars work, bools work, kind of all your primitive types. The things when you type in VS Code that they're blue, they're not green because they're not part of a class. They're kind of a primitive type, as we might refer to it. Now, in order to do the conversion, it needs to be a legal conversion. Most of these will be. Meaning we can convert an int to a float. We can convert a double or a float to a double. But sometimes things won't always work. Okay, sometimes things like that won't always work. Depending on your compiler, converting, say, a double to an int, it might work. What will it do? It'll truncate off that decimal, and then sometimes it might not work. So you just have to consider what's a legal conversion. Will you be doing anything bad with that? And so what is the syntax for this? I also want to put in here, most importantly, that we can do addresses. This is why it pops up here. Today we're going to be talking about addresses. And a lot of times in C, not in C++ necessarily, but a lot of times in C, you will be converting addresses. So we'll even do a little example of that today. It'll be kind of fun. All right. You guys are going to learn a whole bunch of stuff today, so I'm very excited. So the syntax for this is you're going to have some primitive type 1, and then say it's var1, right? Say you're declaring, say, an int, and then you're going to have another type 2 here, var2. Say that's maybe a car. And then if you want to, say, make this explicit conversion to say, hey, I want my var1 to be equal to var2, this won't work. Maybe it will, maybe it won't. But because you're looking here that var2 is a different type than var1. So if we want to convert it, we can do this explicit conversion where we kind of type whatever that type is in parentheses right up front. All right. So I'll give you a legal example of that, and then we'll move on for today. So say we have a character. We'll actually start with just the int. And then we're going to have our character var2. car2 var2, doesn't matter. And we'll say this is equal to maybe, I don't know, the character 5. And we'll say that this is equal to actual 5. And so if I wanted to make sure that this explicit conversion works properly, I can say that var1 is equal to an integer conversion on var2. Does it make sense? Once again, you know, depending on, you just have to be aware of what things are types and what things are not, what things are classes or objects. Oftentimes this will work. You just have to be aware of what you're doing. Okay? It must be legal. You know, the C++ compiler is very lenient. You know, you might be able to shove a double into an int, but oftentimes it might not work the way you think it would. So just be careful of that kind of stuff. So now we're going to get into addresses. All right, we're going to get into a bunch of stuff here. What's the difference between this and a static cast? Well, I'm going to save that for next class, if you don't mind, because today we're going to be to be truthful with you, maybe we can learn it together, actually. I never really use static casts. It doesn't really work. I mean, it does work, but it's not something I ever really use. But let's go ahead and see if we can figure it out together. I apologize. I am merely I'm almost a master in C++. But I am not. Okay. Okay. So let's see here. So that's static cast. Let's put these in the notes. Why not? We're doing some research here. Yeah, I don't like static cast either, Top Wolf. That's why I don't teach it. But I'll go over them. I just have to do my research here. Uchu asks, if R2 was C, what would it output? Does anyone know roughly what the answer to that is? What would the integer variable for that be? Can anyone take a guess while I'm kind of figuring these things out? Yeah, it'll be the ASCII value for what C is. You'd have to look at the table. So this will convert the value at compile time. All right, so that just means when the code compiles, it will make that conversion. Similarly, if you have a dynamic cast, it does the same thing, but it converts the value during the program's runtime. So there's some benefits to a static cast. This is probably why they taught you in 135. The ability to catch illegal conversions at compile time, before the program even compiles. All right? Now with the runtime, you don't have this ability. The program will just break. All right, now let's talk about an explicit conversion. And how it differs from static casts. There you go. What do you know? So the explicit conversion tries a bunch of different casts to see if it works. So the first thing it tries is a const cast. The second thing it tries is a static cast. The third thing it tries is a reinterpret cast. I probably can't spell this very well. And that's roughly what I'm going to leave it at. I'll give you a few links. This stuff is not, obviously it's not very important to me because I've never really run into problems with that, and it's not the main subject of this class, but I'll give you some links if you want to go look at that stuff. Mail, Synthos. I hope that kind of answers it. In a rough sense, an explicit conversion is a static cast. If you want to look at these things, you're welcome to. But the benefit of, say, this explicit conversion is that it will try a whole bunch of different stuff. All right, so, you know, we're looking at these things here. I could go figure out what they do if I wanted to, but kind of the explicit conversion will do it for us. Say, is this one legal? Then I'll do it. So it's kind of a lazy, easy static cast. So I hope you're okay with that. And if you're not, let me know. Otherwise, we'll move on. So now we're going to talk about addresses. Does anyone know what format addresses are represented in? What is the format of an address, or what is it? I think you maybe would have learned this in 135 or perhaps in CPE. It is an integer, yes, but it's represented as a hexadecimal value. So a hexadecimal value, a hexadecimal value is just an integer. All right, it's just an integer. Though it's represented in a base 16. What is the house number? So that's base 16. That's what hex is. Hexadecimal is base 16. All right, we work in the Dewey Decimal System, right? Or binary. So for those of you who didn't know this stuff, numbers, just numbers. Binary means we only use 2 digits, right? 0 or 1. And any number can be represented using binary. It's just a kind of a longer sequence of that, right? There's the decimal system, which everything is represented using 10 symbols, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then there's the hexadecimal system where things are represented using 16 total digits, okay? So kind of more information can be conveyed with a shorter string, a shorter number. And so what does that look like? Well, it looks like this, and then they ran out of the number digits, so they said we're going to add A, B, C, D, E, F. Right, and so you see that Top Wolf there said 1 equals 0, 0, 1, F equals 1, 1, 1. So that's a conversion from, say, hexadecimal to binary. And binary, to represent 16, you need 4 total digits. All right? You need 4 total digits. But in hexadecimal, you only need 1 digit per se. You only need 1 symbol to represent what that value is. All right, so when you see this stuff, when we're working on it, I'm just telling you not to get scared at what you're looking at. You're just looking at a number in a different format. All right, so just as an example of that, in binary, to represent 16, you have 1, 1, 1. Well, let me do something more simple here. 10. So I think that's 1, 1, 0. I'm pretty sure that's 10, where that's, well, let's see, 4 plus, no, it's this, 1, 0, 1. Where this is 8 plus that plus, so that's 10. Yeah, thank you guys. I don't memorize them, I actually do the math, right? You guys remember how to do that math, right? This is 8, this is 1 times 2 to the third. Plus 0 times 2 to the second, blah, blah, blah. I'll let you do that yourself. All right, that's 10, right? Notice in binary, it requires 10 or 4 digits to represent 10. In decimal, you have this. Now that represents only 2. There's only 2 symbols here to represent this. And then finally in hexadecimal, they're like, nah, this is A. So you know that they're just ways to represent values, okay? And the more symbols you have, the less, the less long the string will be. So in computers, we use hexadecimal to represent addresses. So when you print something, an example address, you're going to see this, 0x. The 0x just means this is the hex part, and then whatever value it is. So if we wanted to do 10, it might be 0, 0, 0, A. All right, and that just converts to the number 10. Another example address might be 0x, indicating that this is in hexadecimal. I guess, I don't know. It could really be anything. Usually they come in 4s. Yes, it is the address from your computer's RAM. That's exactly what it is. It's the address from your computer's RAM. And they usually come in like multiples of 4. That's not always true. Actually, it is, because you have things called, well, we'll get into that in just a moment. I'll just give you a silly example here. Could be 1, 2, 3, 4. Who knows? Whatever that converts to, I'm not going to look it up. You can do that yourself. All right. So that is what an address is. Now, guess what? All of our variables have addresses. All variables you use have addresses. All right? What does that mean? That means int has an address. Int x has an address. Car C has an address, etc. They all have addresses. Now, all of your variables have different sizes, and we're going to get into that, but first let's start with looking at that address. So I'll ask you, can we see the address of this variable? And that's yes. Yes, we can. So now we're going to start talking about some operators. Start talking about some operators here. So let's get that going. The first operator we're going to learn today is the... Yeah, Uchu's way ahead of me. Top Wolf, you're almost there. You guys know what I'm talking about. The first operator we're talking about is this. This is referred to as the address of operator. All right. This will give you the address of a variable. All right. It will give you the address of a variable. Now this operator is called unary operator. Can you guys tell me what I mean by unary? What do I mean by unary? Why is this address why is this operator a unary operator? One what? Almost, yeah. It does mean one something, but what do I mean by that? An example of this operator here. So you have int x, and then you could see out the address of x. It takes one argument. Giovanni is the most correct there. Unary operator means that it only takes one operand. That's what we use for that. You could call it an argument if you want. It takes one operand. So here's the operator, and here's the operand. All right. So if you took something like x plus y, this operator here is a binary operator because it takes two operands. The operands here being the x and the y. All right. So yeah, Giovanni's totally on top of that. And this is what this operator does. So let's go ahead and pull up some code. What do you say? Let me pull that over here. And we'll get our code going for today. Today is the 21st. And we're doing addresses today. We're doing good on time, by the way. We're kind of catching back up. I'm happy about that. So for now, we're just going to do addr.cpp. And we'll get started here. I don't think I froze, did I? I can go back if you need, though. I wasn't doing anything. I was just saving saving a file. Let's see here. All right. Whoa. That's very interesting. That was silly of me. Give me 1 second here. All right. Now we're back to the start here. All right, thank you guys. So the first thing I'm going to do is just kind of grab my favorite stuff, and we're going to test exactly what I just said. Now let me ask you this while I'm doing this. Let's say I have int x equals 1, and then I do exactly as I said here. I see out the address of that x. Will this be the exact same every time I run the program? What do you think? Will x have the same address every single time the program runs? What do you think? Giovanni says nope. Mail says no. Uchu says no. No, it does not. Where did you guys learn this stuff? Now, Top Wolf, I would say to be careful with that term. This is kind of considered a static variable in that the address doesn't change during the runtime. So I would just be careful with that, okay? This is considered a static variable, but only because the address will not change during the runtime. So we'll probably put that there in the notes. If you consider it over multiple different runtimes, you could call it static. But that is not what we'll teach here. So let me go ahead and grab it, and we'll run it, and we'll just see exactly what happens. As you can see, I'm working on some stuff here. This is going to be a_ddr.cpp. If I run it, X is here. Look at this giant hex value, 7FFC20C7701C. Oh, looks like it changed there, right? I ran it again. This time it got something in RAM, probably near the same area, but this number's different. We run it again, we get a different address, different address, different address, different address. All right, it could be the same address, just so you know, but likely it's not. Now, why is that? Well, let's go ahead and get in our notes here. Let's kind of come back up here. So first, let's start with this, static runtime variables. Now, these are any variables declared in main or globally. And when I say in main, I see probably the first level of main, in the first level of main scope, or globally, meaning that the address will not change during the runtime. So that's a static runtime variable, and that's what we just declared there. Now, the reason that the address might change during runtime is the operating system is responsible for giving memory to programs. The only reason your program or your computer doesn't die half the time is because the operating system is managing its resources. So it'll only give you memory if it has it, you know? So the operating system is responsible for giving memory to the program. Now, when you compile it, the G++ compiler automatically will put in code to request memory from the OS. All right, so that's kind of when it comes for static runtime variables. All right, that's the static runtime varies. So once again, I'm going to say that the operating system is responsible for giving memory to a program. So when you compile your program, that compiler will automatically put in code to request memory from the operating system. And that happens at the beginning. Every time you call ./a.out, the very first thing it does is says, give me this memory, please. And then I'll use it, and then I'll give it back when I'm done. Okay? Now, if it's a static, well, the truth is you cannot control what address you get. All right? You cannot control what address you get. Though, you can illegally access memory. This is bad. So this means that you use an address that was not allocated for you. Now, some of you have come to me with issues before. Say you run your code on CodeGrade, it's got this weird exit code. You don't know what's going on because the program ran fine on Bobby. Well, I'll tell you what. If I probably told you to run a program called Valgrind, which we're going to learn about either today or tomorrow, and you'll see some of the errors in there. It'll say something like an invalid read or an invalid write. So, and you may have seen that error before somewhere else. Invalid reads and invalid writes refer to you illegally accessing memory that does not belong to you. So can anyone give me an example of, say, what an invalid read or an invalid write might happen? You guys have been using something that you learned in CS135 that makes it easy for you to go out of memory. What is that thing that we use? Add. Giovanni is on top of it today. When you access a part of an array that has not been assigned, I would say it's the array. So to kind of answer that question, Mail says, when you try to read a private member variable, that is not the same. Private is controlled kind of by the program. So that private variable has an address that the program is allowed to access. There's just certain things in the program that are not allowed to read from there. What Giovanni says is that address, right? If you have an array, of say size 10, and you go out of bounds on the edge of it, right? Say you index it at size 10, you've officially gone outside the bounds of that array, and you're now reading from a location in memory that doesn't even belong to the program. And I'll show you exactly how that works. You guys are about to learn something very, very important. So, you guys know that addresses are only passed by reference. Let me just put that here. Let's start talking about, not addresses, arrays. Address and array, I've got to get that fixed. Let's talk about arrays real quick. Arrays are only passed by reference. Does anyone know why that is? So Giovanni says it needs the address, kind of, but there's a deeper part to it. Let's say we've got an array 3. Has anyone tried to print? Has anyone ever done this before? Let me just ask this. Has anyone ever done this before? And do you remember what it does? Let's run it. Has anyone ever done that before? It freaks out. That's a great answer. Do you know what it does? Gives error. Not so sure about that. What is that? What is that? We just learned this. What is this? What is it printing? It's printing an address, right? What is it? Whoops. Where'd my code go? It's an address. So why are arrays only passed by reference? Because you are literally passing the address to the function. That's why. Only passed by reference. Why? Arrays are addresses. Arrays are addresses. So you can't you're passing an address to the function. So that is by definition passed by reference. You cannot pass a copy of that address. I mean, you could, but you're still passing the location in memory. So now let's talk about this. What does it mean to be contiguous? Does anyone know what that is? What does it mean to be contiguous? And then we're going to say dynamic and static arrays. It does sound like continuous, are contiguous. So when we talk about this, we mean side by side. Side by side. So arrays and dynamic, static and dynamic arrays are side by side in memory, are contiguous in memory. So what does that mean? Well, let's get out some visual. It's time for some visual time. I gotta make sure that, I don't see my RuneScape account here or anything. All right. That was just a joke. I hope you're excited. We're about to learn, you're about to learn the secret of the world here, pretty much. The secret of C++ arrays. So let's do the one that we're doing right now. Can you guys see this okay? That's not what I wanted to do. Maybe I'll make it just a little... Yeah, that's okay. Cool. So, this is our array, right? And what did I say here? Let's say that's 2, 3, 4. This is stored 2, 3, 4. Now, I said that this address, this array, I keep getting those things mixed up, but they're the same. That's why I'm getting it mixed up. This array is just an address, okay? So I said 2, 3, 4. So that means x, say, is equal to whatever address is here. So let's say that's 0, 0, 0, 4. Now, this is where we start talking about stuff. Now I say that these are side by side in memory. So there's an address here and there's an address here. Does anyone know what this address is? And it has to do with this. Giovanni says 005, 006. That's not quite right, but you would be correct if it was a character. Klaus has got it. It's 008. Klaus, can you tell me why? And then this one is 0x00, and then it's going to be 12, but that comes out to be, I think, C. Because the int size is 4 bytes. All right, let's go to the notes. Yes. Where are we talking about? What does it mean? So the things are side by side in memory. So when we declare, well, let's kind of start from the basics here. Every data type has a size in bytes. First thing we'll ask is, can we tell the size of a type? Yes. Size of operator. So we'll come down here. I need to kind of split these out a little bit. So that is our address of operator. Now we're going to do a size of operator. This one is a little annoying because it looks like a function. But this is the size of operator. If you go Google it, you will see that it is a size of operator. It is an operator. It's not a function. It's an operator. This is also a unary operator, meaning it takes one operand. And what do these things do? I guess I should say, what do they do? This returns the address of the variable. This returns the size in bytes of a type or variable. So I'll give you kind of another example here. Say we have int x, and I'm going to see out the size of that x. Now be careful, it's bytes we're talking about. We're not talking about bits. How many bits are in a byte? You guys know that? I guess it'd be okay to kind of put this stuff up here. Let's see. Addresses go by bytes. And there's 8 bits in a byte, okay? All right, so this is the smallest amount of memory that you can get from your RAM. You're only allowed to request 1 byte, okay? OS can give you 1 byte at the smallest. All right, so all of this stuff, all this hexadecimal stuff, it goes by bytes. All right, it goes by bytes. So kind of back here in this example, an integer, well, you ask yourself, maybe you don't have to memorize it. You can just say, hey, I would like to know how big my integer is. How many bytes does this take? Well, it's pretty easy. You just call the size of operator here. Now you can put x in here if you want. You could also put an int if you want. Either work. So we'll compile it. And you'll see that an integer is size 4. So now I'll kind of ask you some questions. How big is a float? How many bytes is a float? Integer is a 4. Let's kind of do some, let's do a whole bunch of stuff here. 16, huh? 8. Well, let's see. I don't blame you for not knowing, because I didn't know myself until I started teaching this class. So we can do ints, we can do floats. How big is a character, rather? This one you should know, hopefully. You know how big a character is? We'll do a double. We'll even do a string. This one's kind of interesting. Well, I don't want to do that one just yet. And then we can do something like a short, maybe. And we'll go kind of in the order that they go. 1 byte. Characters are 1 byte. Okay, so I'm actually going to tell you, and we'll kind of run it. Ints are 4 bytes. Floats are also 4 bytes. Chars are 1 byte. Doubles are 8 bytes. Shorts are 2 bytes. I'll even, yeah, some of you are talking about some fun stuff here. We can do a long int if you want. Now, long int I think is 8 bytes. I may be wrong, but I think that's correct. And then if you wanted to do a cout size of long int, I think that comes out as, does anyone know what that one is? 16? I think so. So let's give it all a shot, huh? Let's give it all a shot. And now we're cracking the secret to C++, guys. Did I get that right? Let's see. I said 4, 4, 1, 8, 2, 8, 8. Hey, that's not what I said. All right, well, I probably did something wrong there. Let me try it this way. Let me try it this way. Long int G. Tell me how big that is. Nope, only 8. So go ahead and look that up. Bools, yes. Now, Chef, this is very interesting. Can you guys tell me how many bits does a bool need to work properly? Can anyone tell me how many bits does a bool need to work properly? It's a very simple question. It only needs 2 bits. Or you could say 1 bit. I'm kind of messing up. It's either 0 or 1, right? So it only needs 1 bit, meaning that it's either 0 or it's 1. It only needs 1 bit, but it has 2 values, right? So bools only need 1 bit. But guess what? The operating system can only give you 1 byte of memory as the smallest. So bools will come out as 1 byte. You only need 1 bit to represent a bool, but it will come out as 1 byte. And that's because the operating system can only give you that much memory at the smallest, okay? So now that you kind of understand this, I'm gonna check your knowledge here. All right, so let's pretend we have a character C array that has 3. All right, that's A, that's B, that's C, and then let's pretend we have a double. What do you say about that? A double array, D, and let's say that goes at, say, 1.0, 2.1, and I don't know, 3.1. All right, so I'm going to ask you to tell me what are the next, oh geez, why did you do that? Did I just break the, I don't think so. Give me just that. Okay. So first, let's start with our character array. Let's pretend it starts at 0x 0, 0, 0, A. All right, and that's going to be A, B, C. Can you tell me if this is a character array, where's the next one? Where's the next character located? Where's the next character located? We're working with characters on this one. B, right? And then C, 0, 0, B. And this one becomes... Oh, we're getting a lot of answers here, so let's kind of talk about this. Top Wolf will talk about your pointers in just a moment. You seem to be ahead of me. Yang says this is 0x 000C. So guys, to answer, I guess, Klaus and Uchu, if we're going to start at 0x00A, that's like, say, 10. It's just like a digit. If this helps, we could start it at 1. Now, the size of a character is only 1 byte. So this is only represented as 1 byte here. So the next one will actually be at 1 byte over, which is 2. And then this next one will be 1 byte over, which is at 3. Now let's pretend we're doing the double now. These are going to be the doubles. If I'm starting at 0x0000, where is the 2.1 located? Can anyone tell me that? Where is the 2.1 located? If now we're working with doubles. 008, right? Are you guys kind of getting this? And then this one will come out as 0x00. Well, tell me what this next one is. Let's just see. You guys can tell me what it is. These are cars. This is doubles. Doubles. X. Sorry. 0x00F. 0x00F. Now you have to think about it like this. That this is a +8. And then this is a +16 here. What is 16 in... well... So Cade says F is 15, right? And yes, you're correct. But we have to remember that everything starts at 0. So how many characters... So if you think about it, look at it like this. One double will start at 0, 1, 2, 3, 4, 5, 6, 7. I'll kind of shrink these down. Oh, geez. We don't need it like that. Everything starts at 0 is what I'm saying. Everything starts at 0 here. So a double needs 8 total bytes, right? So that's taking up this 4, and then here's 8. All right, notice that there's 8 total here. So that's what one double needs. So if we put another double next to it, okay. If we put another double next to it, this will continue off starting at 8, 9, 10, 11, 12, 13, 14, 15. Let me see if I got that right. 8, 9, 10, A, B, C, D, E, F. And let me see how well I did there. We're learning here, guys. So that's the first one. Because maybe I did make a mistake. No, you're totally right. You are totally right. You are totally right. See, this is why you guys are here. To catch me from making these silly mistakes. So the first double is here, which goes to 7. The second double is here, which goes to F. So in fact, the next one... Oh, I totally messed it up. So this next one here actually goes to, probably someone mentioned it before, this will start at 00010. Is that right? I think so. Do you guys agree with that? So then this one will become, you're going to take on the very first thing, that's a 1. Right, it's just like, say, if you go from 9 to 10, you take the very first symbol, which is 1, and then you add a 0 to it, right? Am I confusing you? So this would be 0x0010. Now, let's kind of stop looking at this. Let's actually look at it in the code. What do you say? Let's actually look at it in the code. Let's look at it at the code. So first we'll do the double for fun. And that's what we say there. Now we're going to say cout. Now let's say I wanted to get the address of the first element. What do I type? If I want to get the address of the first element. If I want to get the address of the first element in the array D, yes, that's exactly right. Also, can anyone tell me what else I could type? Is anyone? I'm willing to accept some creative thoughts here. This will work. It'll be the address of this, yeah. There's something else that works here, right? Did you know that this is the same thing? Because what is an array? It is an address. And where does the array start? It starts at the beginning of that. It starts at the beginning of that array. It's the address. So that is actually the address of D0. But for these ones, you're going to want to do that. So let's go check it out on the code. And let's see how we did. All right, so here's our first one, right? That's where the array starts. Now to go to the next one, we add 8. Do you guys see that? That 8 is added between this first one and the second one here. And then we go to the next one, right? This is not an F. I made that mistake. I think we froze. Did we freeze? Are we back? All right, thank you. So you notice here that we've added 8, and then this one we've added 8 again. So I'm going to ask you this before we move forward. Do you understand what it means when I say an array is contiguous in memory? It means that things are side by side. Things are side by side. Do we understand that? Now maybe to sink my point a little bit further, let's say I did this. I want to access dia3, like half of you do, right? We all do it. I want to access dia3. What happens here? Well, you actually will add, we'll get into this next. You're going to add 8 to this array, this address. You're going to add 8, and you're going to step outside of the array. And you're going to say, please give me the location or give me the value at this location. So it will be at 198, right? Now that address, 198, does not belong to you. It belongs to, it might be free. Well, let's talk about that, cool Turbo. You say, what about the and before the D? Well, this will give me the address there. This address doesn't belong to us. All right, but what if I wanted to access the value, right? If I say, give me this. Giovanni says we'll get a junk value, right? This gives us a junk value. This gives us the value stored there. Either way, these are both invalid reads. Does that make sense, Turbo? These are both invalid reads. This will be the address that doesn't belong to us, and this will be the value that's stored there. And that actually kind of segues us into our next little subject here called dereferencing. Now, someone said it before. Have you guys heard that term before, dereference? I think Top Wolf mentioned it a little bit earlier. Let me see if I've got everything about arrays, right? All right, data types, let's do that. Does anyone know the dereference word? The big D word? Data types. So if we summarize what I said here, arrays will be as big as they need to be. Based off the size of the array and variable. So you could say, how big is our array? Did it stop? No, it's back. Okay, that was my internet. I didn't reset the stream, but my internet disconnected. I'm sorry about that. Okay, so I'm gonna kind of go back to before all of this mess happened. Synthos asked, why do arrays store junk values into its memory if it isn't declared? Ah, that's a great question, Synthos. So, back to our Excel sheet here. I love this Excel sheet. Make everything, I don't know, white here. So this is your free floating memory, okay? Excuse me, that's exactly what it is. All right? This is our free floating memory. Now, this memory was probably used by your other programs. Minecraft probably stored your damage variable in here. You know, you had your wooden sword, so it's got 12 something stored in here. So it's kind of just like 111, 001, 1010, kind of a bunch of stuff like this. Now, if I wanted this to be, let's see here. If I wanted this to be a proper width, I'd maybe give it 6. And then I would say format cells. I would say custom. And I would say please represent these things as 4. Thank you. So this is just your free floating memory. From the last time your computer used it. That's your RAM. That's your dedicated WAM. As I'm sure you guys have seen that before. So then you say, hey, computer, I need an array of size 6. I need an array of size, how about 5 instead? Say, computer, give me an array of size 5. It says, hey, this address here, 0x004, is open. You can have this. And so it passes it to you. Here you go. That now is yours. Now that's all it does. Synthos, that's all it does. It says this is yours. You can have it as is. So you ask me, why are there junk values in it? Well, because they didn't change from the last time the program ran. It's just, that's the RAM. That's how it was left. That's what the memory looks like. It says, hey, you can have this. You can have this array. You can have this contiguous array, and whatever's in it is in it. So when I ask you to initialize all of your values to 0, please do that. Because what is this? This is 15, sorry. This is 15, this is 1, this is 10, this is 0, this is 11. No, don't listen to me. That's like 8 or 9, I think. I don't know. Stop listening to me, okay? It's from other applications, okay? Yeah. So that's why you get junk values. It's 5. I am terrible. Please please leave me a good Rate My Professor review. I promise I know what I'm talking about, okay? I just don't memorize this stuff. I write programs to do it for me. All right, so hopefully that answers your question. And we can get back on topic here. So now we're talking about dereferencing things. So we're kind of getting back into arrays, our addresses. So we'll come back up here. So I ask, how can we get the value stored at the address? This is called dereferencing. Dereference. Use the dereference operator. All right, so how do we get the value stored at some address? We use the dereference operator. So there's actually 2 dereference operators. Someone mentioned it before. What's the first dereference operator? What's the first dereference operator? There's two of them. Yeah, the star, right? Where did you guys learn this? What class taught you this? There's the second dereference operator. This is the first class that I've ever had that knows that. Oh. I'm sorry. I understand. It's a binary. So for those 135 or 202 guys, do you know what the binary dereference operator is? I'll be so happy if you do. What's the binary dereference operator? You've used it before, actually. We were just using it. We'll give the value stored at the address. Chef, you were kind of right. We'll get to that next class. I prefer this one. Did you know that this is a dereferencing operator? Did you know that? This will give the value stored. I'm going to put an I in here. Yeah, it's an array. I'm going to show you exactly how it works right now. This your whole mind is about to be blown. This will give you the value stored at an address plus offset I. Give you the value stored in an address plus offset I. So check this out. Time to learn. Time to learn. So this is our D stuff here, right? This is our D stuff. So the first thing we'll talk about is just this, rather. We've kind of got a lot of stuff going on here. We'll start with an int x. If I wanted to get the address of x, I would say, see out the address of x. And then if I wanted to get the value stored at that address, I would say, this is kind of redundant, but I would say, give me the dereferenced version of that address. So you understand that this is, in some sense, these are both unary operators, right? This is and applied to x, and then this is the dereference operator applied to this whole thing. All right, so this gives us the address, and this gives us the value there. We'll run it just to prove it to you, to show you that I am not crazy, maybe only mildly. It's 1. Okay, that's 1. Obviously it's 1. Why? Because that's what we put there. We said put 1 there. So now it's time to learn the real stuff. Tell me. I want to see if we're understanding. I want to see if we're understanding. What happens if I do this? Can anyone tell me? What happens if I do this? What prints? Can anyone tell me? What will print if I do that? .0. Why is that? Well, it's kind of like this. C++ is just full of these things, right? So D, the D is an address. D is an address. So I'll take that away. D is an address. And what is stored at the very beginning of that address? Well, it's this 1.0 value. So if I dereference it, I'm going to get this back. I'm going to get back 1.0. Now, obviously, if I do this, I'm going to get back 2.1. Now, guess what this is doing? This is offsetting. This is what this does. Let's kind of pull up some notes here. So what does the brackets do? These are the brackets. And this is our star. All right, this is going to be a test question too, by the way. We'll review it next time, though, so don't freak out yet. So whatever, I'll clean these notes up, but whatever size of the data type is, I think this should be better represented as an example. Let's do that instead. So say we have this double D3. Okay, and let's pretend it's equal to some values. Dot, 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 dot. And so the type of this array is a double. So the size of a double is 8. This is 8. So the size of the array is 8 times 3 equal to how many total bytes is that? Well, I think that's 24, right? 24 bytes. 24 bytes for the whole array. And the values are stored at 0 through 7 bytes, right? That's kind of the first value. The next value is stored at 8 through F bytes, right? And then the third value is kind of stored at, I guess we said 10 through probably 18 bytes, right? So those are where the values are stored. And so when we call the dereference operator, we're going to reference what the size of that type is. All right, I'll kind of get back to that later, next class. But it's going to reference what type is it? Well, it's 8 bytes. So I'm going to grab these 8 bytes. And I'm going to, yes, you're right. I'm going to grab these 8 bytes and I'm going to see what's stored there. All right. So D0 is the equivalent of D. Okay, D is our address plus some offset. What is the offset? It's 0 times 8 bytes dereferenced. It's the address plus 0 times 8 bytes dereferenced. So let's look at the next one. D1 is the same as D, whatever that address is, plus 1 times 8 bytes. So we said that this would say 0, 0, 0, 0x00. This is 0x008. That's where it begins, right? That's where it begins. It begins there at the 8. So then D1, D2 is the dereferencing of the original address of D plus 2 times 8 bytes. And that gives us 0x010. Do you see how this is an offset? And so all arrays are contiguous in memory, meaning they're side by side. So if we know what the size of the type is, then we can access the elements from the starting element. So I'm actually just going to do this. Check this out. These are the same. If I see out the dereference of D, if I see out the dereference of D0, or if I see out the dereference of D plus 0. Similarly, if I print D1, I can also see out the dereference of D plus 1. Now, I'll have to come back to this next time because I want to put it in the notes. I said that this should be something like 1 times the size of double, right? I did say that. This should be something like 1 times the size of double. But the compiler would know, the compiler knows what I mean by this. Okay, the compiler knows that I'm talking about the size of a double. Mail asks, why would we use the star? Because that's a dereference operator. So there are 2 dereference operators. There's the star, which will give us, it's a unary operator. The star will just give us a value stored at an address. The brackets will also give the value stored at an address plus some offset of I. So what I'm saying here is these are the same exact thing. This is the address dereferenced at an offset of 1. This is also the address dereferenced at an offset of 1. Do you guys follow? Have I gone completely off the rails here? Have I gone completely off the rails here? Tell me. Have we lost it? So Uchu says, we only use star to output a value. Do we ever use it to change values? Uchu, yes. You're right. I will get that. I'll get to that next time. You say I'm still on the rails. So why would... No, so you're right. Male, there's no reason to do that. There's no reason to do that. But Top Wolf says it correctly, and so does Chef. Yes. So Chef is correct. D plus 1 is the address of D1. And Top Wolf says D1 is equivalent to star D plus 1. Yes, that is correct. So, Male, to answer your question, no, you would not do it this way. Basically, the people who made G++ said, we do this too much. So I am going to shorthand it to this. But it's your job as the 202 student here to understand that these are the same thing. Knowing what this does and knowing that it's the same thing as this is very important. And it also will keep you from going out of bounds on your arrays. So that's what it does. It takes the starting position of our array, the address. It adds some number of bytes to it, and then it dereferences to grab some value. So yeah, you would not ever do this. You could if you wanted to. But if you went to, say, your job interview and they said, you know, get this value out of this array, and you do it this way, they'll be like, I don't know why you did that. It is correct, but I still probably won't hire you. Just know that they are the same thing. So next class, we're going to continue on with our address discussion. There's still quite a bit we have to cover. But I hope you learned something today about addresses. We kind of went over a bunch of stuff. We talked briefly about this conversion stuff, which is not super important. We'll get to it next time. We talked about what addresses are, and then we kind of did some address acrobats, right? We learned about a few operators. In next class, we'll come back to it. Okay, so thanks for coming to class today. I'm sorry for a few little interrupts. Those always seem to happen. These notes and these codes will go up on Web Campus. And I'll see you guys next time. Top Wolf, you have a great day. Oyman, you're welcome. Kane, you're welcome. Synthos, you are welcome. Uchu, you're welcome. CS202 student, you are welcome. Cade, have a great day. Waffle, have a great day. Chef, have a great day. Fuzzy, I will be sure to hydrate. I will see you on Thursday. YCS, you have a great day. Young, you are welcome. Giovanni, you are welcome. Hannah, you are welcome. And Brandon, you are welcome. I'll see you guys all next time.